All right, we are doing, hola, mi clase. Sorry, a little distracted. We are doing 4.5 Systems of Linear Inequalities. So we are combining everything we've done so far, 4.1, 4.2, 4.3, which was all systems of equations, and then 4.4, which was linear inequalities, with, they're going to be combined together. That's what today is. So basically kind of in a sense 4.1 combined with 4.5, right, graphing. So a system of linear inequalities is where we take two inequalities and figure out where they have crossing or, intersection, just like we did with systems, right? So just like in systems, we had to figure out where they intersected. The difference is now we have some shaded regions that we have to figure out where they intersect, okay? So the solution will be where they intersect, where they mesh, and where they blend in a sense, okay? So we are going to graph the system and figure out where they intersect, and that will be our solution. So the way we do this is we just treat these like two separate problems, all right? So I'm going to graph the first one in purple. Oh, that's not purple, that's red, so we'll just stick with it. And then I'll graph the second one in purple. So my y-intercept's -2, and my slope is 1. So I'm going to put as many dots as I possibly can, because I don't know where the other graph will intersect this graph. So just like a system, we have to put all of them. Now I'm going to put a dotted line because it's a greater than, no equal to situation. And then if we look, I want it to be greater than. So -2, what's greater than? Up here. 2, what's greater than? Up here. So it's going to be this space in here. All right. So now I'm going to go and graph the second inequality in purple. So my y-intercept is +1, which is here. Hopefully that shows up okay. And then we're going to go -1, 1. So this direction. And I got to go the other way as well because I need to see where the two fully intersect. Now this time we're going to have a solid line because it's equal to. All right, equal to means that is a part of my solution. And then this time I want everything to be less than or equal to. So here's 1, I want it to be less than. And here's 3, I want it to be less than. So this is then the solution to the other inequality. But what we're looking for is what makes them both true. And the only space that makes them both true is this double overlapping space. So that's my solution. That's because this space doesn't make the purple line true, and this space doesn't make the red line true. And so the only area that actually makes them both true would be this line and everything in between the two lines. Okay, and this line's included because it's an equal to. This one is not included because it's not equal to. All right, so this time they gave us two inequalities and they want us to find out what the inequality, or sorry, they gave us the graph, they want us to find the inequality. So we just treat them like two different situations. So if I look at the blue line, it's an equal to, right? Y is going to be equal to. We actually can decide that y is going to be greater than right now because if you notice, it's all the stuff above it, right? This is at -1, I want everything up here. That's where this double shading comes in because it's overlapping right here. So this is for sure a greater than situation. And then we just need to find out what the line is. So the y-intercept's 4. It's positive, so I'm going to put plus. And then it looks like I go down 1, right 1, down 1, right 1. So my slope is -1, so I'm just going to put -x. So there's the first one. All right, so then I'm going to change this to red, well, I guess it's more of an orange, so I'll change it to orange. So y, we know it has to be greater than or less than, no equal to, because it's dotted. If I look, my y-intercept, it's the space below or less than, even for my overlapping space. So this is actually a less than situation. My y-intercept is 3, so I'm going to go plus 3, and then I'm going to find my slope. It looks like I go 1, 2, 1, 1, 2, 1. Yep, so my slope is 2, so it's 2x. And there is my system that made this graph, and that's their overlapping space. All right, so this time they gave us 2 lines, but they want to know what system would make these 2 points true for both of them. So if I plot those points, 1, 2, and then 2, 4, it means that the only way that they would be equal would be this space right here in between, right? How would I make them true? So if we look, the first one's going to be y is less than or greater than. And this y-intercept's 2. It's positive 2. And my slope is negative 1. If you guys notice, I'm going down 1, right 1. So this is, again, negative x, but plus 2. And for shading wise, if I shade this in blue and I want it to meet these points, the only way it's going to meet these points is if I shade up here, right? So that means it needs to be a greater than or equal to. Oh, no, not equal to, because it's not solid. Okay, so that's how it meets the blue line. So then if I go do the orangey red line, this one isn't equal to. The y-intercept's negative 3. And my slope is, it looks like there's another point. Of course, I can't even see. Right there. There it is. I had to uncover it to find it. So 1, 2, 3, 4, 5, 1, 2. So 2, oh, 5 over 2. I don't know why I put 2 over 5. 5 over 2x. And then same thing, if I go to shade it, to meet these, I need to go up as well, which makes all of this shaded in. And then you can see they now both have those in common. So we would need this to also be greater than, but equal to. It's the only way they both meet those points. All right, I made an edit to this, but I just, it's because it's the exact same as the first one. See, greater than x minus 2 and greater than or equal to and negative x plus 1. And then I got to here and realized that's exactly the same thing. So I made an edit. We're going to change this to plus 2, so make that adjustment. And I'm going to make this a minus 1, so make that adjustment. What I'd like you to do is pause and graph these inequalities and see if you can find the solutions. And then actually I'm going to kind of make this your independent practice. And so we're going to go over this when we get back into class, okay? So just make sure you made this edit though, that it's plus 2 and then it's minus 1, because it's that way it's different from the first one. All right, so here is a story problem. Malia has $500 to purchase water bottles that are $2 each, and that some socks that are $3 each for a fundraiser. So for her cross-country team, she needs to buy a total of at least minimum 200 items without buying too many of just one item. Create a graph that shows the possible number of water bottles and pairs of socks that Malia should buy. So we're going to write two systems in standard form. Okay, so why don't you pause here and see if you can find the equations that would help me solve this. All right, so our first equation, I'll do it in red, is combining the money. So 2x, I'll make the bottles x, okay, plus 3y, my socks are y, I guess it should be over there, but that's okay. And I need that to be less than or equal to the $500. I can't spend more than $500, so it needs to be less than or equal to 500. Okay, now if you have this completely flipped and it says 500 is greater than or equal to 2x plus y, you're fine too. It's exactly the same thing. So then the other equation is that I need to buy some bottles and I need to buy some socks, and it needs to be at least 200 items, which means I can buy more than 200 items, but minimum it has to be 200, okay? So we need to then graph these. So I'm going to write our graph for us. My graph goes by 20s. So 20, 40, 60, 80, 100, 120, 140, 160, 180, and so like 200 is this very, very top line, right? And then across this side, mines go by 40, so 40, 80, 120, 160, 200, right, am I doing okay? 240, okay, 280, and then this would be 320. All right, so we can graph these. We actually can graph them using our standard form. We can use our x's and y intercepts if we want. We can change them to slope intercept form if we want. This one's pretty easy to graph in standard form, just because if we cover them up, my y-intercept and my x-intercept just happen to both be 200. So my y-intercept's 200. Oops, let me do that in purple or blue, whatever color that is. And my x-intercept is actually 200 as well, and since these go by 400 or 40s, this is 200 here. Okay, it's equal to, so I'm going to make a solid line and connect those two. And then I want everything that's greater than this. Okay, maybe I can even make a, oh, I wish I could get a little different of a, oh, there we go. I'm going to make it a little lighter. I don't want it so dark. More of a light blue to shade it in. I want everything to be greater than, so it's going to be this space, right, for the blue line. Now for the red line, we can, again, either do it in slope intercept form or just use our intercepts. Now, dividing by 3 is not as perfect. It comes out as an awkward y-intercept. It's just slightly over 160, right? If we divide 500 by 3, it's like a little over 160. So we can kind of put it right here. It's fine. But this one's nice and easy. It's exactly 250. But again, that kind of means we have to estimate down here. This is 240, this is 280, so maybe right around here. Okay, I'm just doing some estimating. We, again, want it to be solid. Let me change my color because it is equal to, oh, it didn't change it. It's not helpful. There we go. Like this. All right. And then for this one, we want it to be less than, so again, I'm going to pick a little lighter of a color, and everything that's less than this line would be here. And if you notice, and I can color this in even more, the only space that they overlap is this itty bitty tiny sliver, or, oh, so small it doesn't want to even shade, is this spot right here. That's the only area that they have in common. So then it says, use your graph from Malia's problem to determine if Malia can buy 75 water bottles and 100 pair of socks. So if we remember, our X's were our water bottles, right? Down here is the bottles. Except I can't spell. Shh, don't judge me. And this was the socks. So if we go find 75 water bottles, that's around here, and 100 socks, which is around here, would that even work? Okay, so you decide, would that even work? What could I buy 75 water bottles, okay, and 100 socks? Would that work? Yes or no? Tell me why not. Okay, and we'll go over that when we get back to class. All right, so things to remember is graph them separately. I'm going to type this for you guys so it's a little bit easier. Graph the two inequalities separately. Sure. then see where the shading intersects. I'm pretty sure I spelled this wrong, but yay for me. All right, that's it. So until next time, adios.